Hello to all of you. In this video, we are going to discuss two important topics. Names of two important topics are accuracy and precision. Starting from accuracy. Accuracy in measurement is defined as the closeness of our reading to the true value. So it is the closeness of reading to true value or actual value. When we take measurements, we always take multiple readings. So, which reading or which set of reading is much more closer to the true value? Let's say, for example, the true value is 1.1 cm and we have measured three readings 1.0 cm, 1.3 cm, 1.4 cm. So you can see in these three readings, this 1.0 is the one that is closest to the true value. So if we compare these three readings, which one is much accurate or more accurate is 1.0 centimeter. So that is how you define accuracy is. That if you're taking readings, if you're taking measurements, how much my reading is close to the true value of any measurement. Now we have the second one, which will going to discuss in detail. This topic is going to discuss in detail, and that is precision. Okay. So now, precision of an instrument is defined by two ways. One is defined with respect to the instrument, and the other has been defined in respect to a measurement. So now, let me define precision in terms of instrument first. So precision in terms of instrument. See, any instrument can measure reading precisely, but it has some limit. Let's say I have a meter rule. I have calipers, vernier calipers. I have micrometer. And you must have know about the least count. Least count means it is the smallest reading an instrument can measure precisely. The word is there. Precisely. So the smallest reading the meter rule can measure is 0.1 cm. The smallest reading vernier calipers can measure is 0.01 centimeter. The smallest reading a micrometer can measure is 0.001 centimeter. So see, we can measure precisely. The precision of an instrument, it depends upon the number of significant figures. That is one more point. The precision of an instrument, it depends on the number of significant figures. So you see here that meter rule can measure up to 0.1 centimeter. It can measure precisely up to 2 significant figures. The calipers can measure up to 0.01 centimeter, up to 3 significant figures, and micrometer can precisely measure reading up to 0.001 centimeter, up to 4 significant figures. So that precision depends on the number of significant figures. You can state this in a way that if you are measuring something, this first digit after decimal place is cleared in meter rule. If a second or a third or a fourth digit is coming with a measurement of meter rule, that digit is unclear, that digit is not precise. And the same has been practiced with the calipers, that we can measure up to up to two digits after decimal places precisely. But if it has the third one, if it has the fourth one, if it has the fifth one, that is uncertain, that is not clear. And the same has been practiced with the micrometer. We can precisely measure up to 3 digits after a decimal place, but if the fourth digit is there, fifth digit is there, sixth digit is there, then it is not accurate. Every instrument has some limitations. I am not saying that if an instrument is lesser than 0.1 centimeters, so you cannot measure it with the meter rule. You can measure it with the meter rule, but the second and third digit is not precise. Your reading will have some error, and we have to calculate the magnitude of that error by using uncertainty. The similar has been practiced with the calipers, the similar has been practiced with the micrometer. So that is the precision of an instrument. And as we are going from meter rule to the micrometer, as the least count of an instrument is increasing, the precision of an instrument is also increasing. So that is how you define the precision in terms of instrument test. So as we are going from the meter rule to the micrometer, the least count increases and the precision also increases. Now, how you define precision in terms of measurement? Precision in terms of measurement. See, if a reading are close to each other, you are taking four readings. One is 1.1 centimeter, one is 1.2 centimeter, one is 1.0 centimeter, and one is 1.3 centimeter, let's say. So you are seeing this reading, these readings are close to each other. They are not like that. Like one is 1.1, one is 1.9, another is 2.2 centimeter. Let's say take this as 2.5 centimeters. So you see here, these readings are not close to each other. They are far away from each other. But these set of readings, they are close to each other. So the closeness of a reading to each other, how close are reading to each other. So in a measurement, it is defined as closeness of readings to each other. That's how you define precision in terms of measurement. More importantly, the precision of an instrument is a detailed thing that we have discussed, and the precision in terms of measurement is defined and is well explained by using the examples that I have listed here. Now, I have a graph. Any measurement can be precise and accurate at the same time. It can be precise and accurate at the same time or not. So we, with the help of these two or three graphs, we are going to understand this relationship where in the first graph we will see the instrument is precise, the readings are precise and accurate. Sorry, not in terms of instrument, we are discussing in terms of reading at the moment with the help of this graph. So let's draw this graph. Let's use this graph. First of all, I will draw this graph and explain it to you. On the y-axis, we have reading, and here we have number of readings, or we can say the number of times in which the reading is coming in our measurement. So let's understand this graph very clearly, that on the x-axis I have plotted the reading that I am taking in any measurement, and that reading is coming 2 times, 3 times, 4 times, or 5 times. The number of readings that is coming, how many times, this has been plotted on the y-axis. So let me draw my first curve. Let's say here is the true value, and the curve that I have drawn is look like this. Curve is not very big, very large, is not spreaded along the whole graph. If you see this reading, these readings that it is plotted here, these readings looks like close to each other. These readings looks like close to each other. The graph is not well spread. This curve is very narrow. Readings are very close to each other. So if readings are close to each other, it means the reading that we are taking is precise. And there is one more interesting thing. The true value is also present in our curve. And let's say if we do this, it can tell us how many number of times this true value is coming in our measurement. So graph is narrower, it means the readings are close to each other, and true value is also lies in this graph, in this plot. It means that if the true value is lying, it has been accurate as well, and if they are close to each other, it has been precise as well. So you can say that that measurement is precise and accurate at the same time. That's what I have been talking previously. That sometimes it can be precise, it can be accurate at the same time, or sometimes it cannot be precise, it cannot be accurate. So I will draw the same graph to discuss or to tell the similar thing to you. Now let me draw the graph first. So we have x and we have y axis. Readings on the x and number of readings on the y. So now the true value is somewhere here, let's say, and the graph I am about to draw is like this. The graph is well spread now as compared to the previous graph that we have seen. This graph is narrower, this graph is well spread, and also in this graph true value is not lying in the graph. True value is here. True value is somewhere here. It is not lying in the graph, not coming in the graph. And graph is not narrower now, it is well spread. It means readings are not pretty much close to each other. So this graph is telling us that readings are not precise and not accurate. So I can write this as now, this graph is as not precise and also it is not accurate. So it is not necessary that every time the readings you are taking are precise and accurate at the same time. In the first example, I can see that they are precise and accurate at the same time. In the next example, they are neither precise, not accurate. Now, let's come on to one more thing, one more graph. The last graph to understand these things. Here we have the reading. And here we have the number of readings. Okay. Now, the true value is somewhere, let's say here. And the graph is like this. Well, let me draw it one more time. See, graph is narrower. It means readings are close to each other. It looks like pretty similar to that one. It means that this graph is precise, this measurement is precise, but true value is very far away from this graph. It is somewhere here. So that is the case. Can you guess what is happening in this case? The graph is precise, but true value is not coming in there. It means it is precise, but not accurate. So it can be precise, but it cannot be accurate. So understand this thing about accuracy and precision. It can be precise and accurate at the same time. It cannot be precise, cannot be accurate at the same time. Sometimes it can be precise but not accurate. So that's how the measurements, the topic of measurements, the topics of precision and accuracy goes through. So that is all in this video. In the next video, we are going to discuss a new topic, that is uncertainty. So until then,